Sup? Next lesson. Title is there. Learning objective is there. Whilst you write it down, make sure you pause the video so that you've got time to do it. And when you're ready to keep learning, press play. So we're going to first of all just learn a key term that I actually forgot to teach you, and I'm sorry about this, in your first lesson. So here's your circle. And if we take a part of the circumference, let's say from here to here, we call this an arc. An arc is a part of the circumference. It doesn't matter how big it is. It could be that big, or it could be most of the way around the circumference. Doesn't matter. It's just a part of the circumference without being the full circumference. So make sure you've written that down. Go and add it to the diagram that you drew a couple of lessons ago. An arc is a part of the circumference. It's going to be important for today's lesson. So, if I showed you a full circle and I told you the diameter was 12 centimeters, I'm sure at this stage you could tell me what the circumference of this circle was. Pause the video and just make sure you can do that. Well, circumference is the distance around a circle. How do you find it? Pi times d. So pi times 12. I'm going to leave it in terms of pi for the moment. But if I wanted to find half of the circumference, so I found an arc, the length of this arc in green, which is only around half of the circumference, how would I find the length of that? Can you think? Well, because we're dealing with half of this full circumference, half of C, all we have to do is think of in maths as times. We know the circumference is 12 pi because we figured it out already. And so to find the length of the arc, all we have to do is the fraction of the full circumference that we're dealing with. So the fraction of the full circumference, which is that. Now I'm sure you'd be happy to tell me a half of 12 pi is 6 pi, but just to be really clear about it, you could say 12 pi is the same as 12 over 1. Always make your life simple. Simplify first. And so this is 6 pi. Now what about if we were dealing with just a quarter? So if I wanted to find the length of the arc that was only a quarter of the circle, how would I find that? Pause the video and have a go. Well, again, we're looking at this strategy over here. We calculate the fraction of the full circumference. So if we're dealing with just a quarter, we do a quarter of the full circumference, which is a quarter of in maths means times 12 pi. And again, you may be able to tell me straight away that that's 3 pi, or you could always make your life simple, simplify first, top, top, bottom, bottom, get 3 pi, should be centimeters, as the length of this highlighted yellow bit. But the key message, guys, is that whatever fraction of the full circumference that we have, that is what we're going to times the full circumference by to find that part of the circle arc. Let's do one more. This time, I want to find, I'll tell you the diameter is still 12 centimeters. But this time I want to find, let's go with a sixth. So I'm telling you that this is 1/6 of the full circumference. How would I find how long this arc is here? pause the video and have a go. Well, if we're dealing with a sixth, it's a sixth of the full circumference. So it's a sixth times, because of in math means times, 12 pi. Always make your life simple. Simplify first. Multiplying fractions, top, top, bottom, bottom. And so the length of that arc is 2 pi centimeters. So just make sure you've written down very clearly the strategy when you're trying to find a fraction of the full circumference is you do the fraction times the full circumference. And when you're ready to move on, do an example, restart the video. Well, don't restart it, but you know what I mean. Pause it now, then press play, and you know what you're talking about. It's been 2 months of this. Right, here's an example where we're going to use this strategy. So find the perimeter of this semicircle with diameter where d equals 60 centimeters. So I'm going to just write 60 here. Give your answer rounded to 1 decimal place. All right, well, have a go. So pause the video, do this on your own, press play when you're ready for me to go through. All right, well, perimeter is the distance around a 2D shape. So to find the perimeter of this shape, I have to find the distance over here, which I already know is 60. So it's the straight bit. And it's also added to this distance here. So it's the straight bit plus the arc. It's not a great diagram. There we go. So what is the length of the straight bit? I can see straight away the diameter is 60, so that's that. Now how do I find the length of the blue arc? We go back to the strategy that we wrote down at the beginning of the lesson. It is the fraction of the full circumference that we're dealing with. Because this is a semicircle, it's half of a circle. So I'm doing half of the full circumference. Now we've got to figure out the full circumference. I'm going to do this in, let's do it in red over here. When I write circumference, I mean full circumference is pi times d. We know that diameter is 60. So I'm going to leave it in terms of pi like that. So to be clear, that is if the circumference went all the way around the circle. If we were finding the full circumference, that would be it. But we're not finding the full circumference. We are trying to find half of in mass means times the full circumference, which is 60 pi. And so we do 60 plus half of 60 pi, hopefully you can see is 30 pi. But we're being asked to give our answer to 1 decimal place, not in terms of pi. So we have to do 60 plus 30 pi in our calculator. When we type all that in, we get 154.24, and then some more stuff, centimeters, which rounded is 154.2 centimeters to 1 decimal place. And that's our answer. So pause the video and make any notes that you need to, and then press play when you're ready to keep watching. Example number 2. You can definitely try and do this on your own now. So pause the video and press play when you've given it a go. All right, so remember you've got to be honest with your purple pen here. Find the perimeter of the semicircle with radius r equal to 28 centimeters. So we know the length across here, just here, is 28. Which means again across here is going to be another 28. So the perimeter is going to be 28 plus 28, which is these two bits combined, that's the straight bit, plus the curved bit, the arc of the semicircle. So the question is all about finding the length of the arc. So just 28 plus 28 is, why can't I think, 56. And then we have to find half of full circumference if it were a full circle. Again, the full circumference is if it went all the way around. Circumference is the distance around a circle. How do we find it? Pi times d, which is pi times 56, or 56 pi. So I'm going to write 56 plus a half times 56 pi. Why don't I do it in red to keep it the same color as where I worked out before? There you go. And a half of 56 pi is just 28 pi. And so it's 56 plus 28 pi. And we're asked to leave our answer as an expression in terms of pi, which means we have to leave it like that, centimeters. We cannot combine the 56 centimeters and the 28 pi centimeters because they're not like terms. You can think of this as being like 28x and 56 in the sense that you can't combine them because they're not both pi. If it was 56 pi plus 28 pi, then we could combine them, but it's not. So that's our answer. That's it. So make sure you've purple penned it. If you tried to calculate it and you didn't leave it in terms of pi, then make a note saying how to leave it in terms of pi. Make sure you're being honest with your purple pen. Pause the video so that you've got time to do all that and press play when you're ready for another example. So, whoa. Here, we've got a different shape. You're going to try it on your own again. Pause the video and have a go. So find the perimeter of this quarter circle with radius r equal to 50 millimeters, which means that is 50 millimeters. So the perimeter is the distance around the circle. Sorry, distance around a 2D shape. So we're adding that, plus the arc again. So we can see the first yellow side, it's labelled for us, is 50 millimeters. The vertical yellow side, now remember this is a quarter circle, it says it here, which means both this and that, these are both radiuses, and so therefore that is 50 millimeters as well. The final thing we have to add is the arc, which is that length there. And to find that, we find what fraction of the full circumference it is. Well, in this case, if we made the circumference all the way around, you can see we've only got a quarter of it. So it's going to be a quarter of the full circumference. So 50 plus 50 is 100. And then we've got a quarter times, of in maths means times. And now we just need to find what the full circumference would be. So circumference is the distance around a circle. How do we find it? Pi times d. The radius is 50, so therefore the diameter is double that. So the diameter is 100. So the full circumference is 100 pi millimeters. A quarter of 100, or a quarter times 100, is 25. You could have written it out as a fraction. And that is our full perimeter in terms of pi, which is what we have to do in the question. So again, pause the video and make any notes that you need to. Press play when you're ready to keep watching for, I believe, one more example. Right, now then, what is this monstrosity? Well, it's example number 4, isn't it? So a running track has 2 semicircular ends with radius 29 meters and 2 straights of length 91.3 meters as shown. Calculate the total distance around the track rounded to 1 decimal place. So, I want you to pause the video and have another go. Press play when you're ready for me to go through it. Right, well, the total distance around the track is otherwise known as the perimeter, which means we need to find the length from all the way around here. We've got this length here, and hopefully you'll see why I'm doing these in different colors. So we've got to find all those distances there. Now the yellow distances, they're pretty easy. We know they're 91.3 meters. So immediately the perimeter is going to be 2 lots of the yellow distances, which is 91.3 plus 91.3. And then if you can, this is the trick with the highlights, this is why I like doing it, this is why I've done this. If you combine the 2 blue highlighted sections, I wonder if I can do that, maybe I can't. You can see that one there on the left, and this one there on the right. What do they make? They make a circle. So this question is a bit tricky, a bit sneaky, because it might make you think you should find the arc of a semicircle and then the arc of another semicircle, but actually combined they make a nice simple full circle. Now the radius here of this semicircle is 29. The radius of the other semicircle is 29. So what's the diameter overall? It's double 29. The total diameter is 58 meters. And so this time we're not even finding a fraction of a full circle of the full circumference. It is just the full circumference because it's all the way around the blue highlighted bits, which is therefore circumference is the distance around a circle. How do you find it? Pi times d is pi times 58. So now I'm going to add in my calculator 91.3 plus 91.3 plus 58 pi. I'm going to get 364.81 meters. And then I'm going to round it because it's saying it wants it rounded to 1 decimal place. So 364.8 meters to 1 decimal place. And that's it. So if you miss that little trick there with the arcs, the semicircles actually being part of a circle, and make a purple pen note of it. And good luck with today's Hegarty task. And obviously email me if you're still struggling with anything.